Imagine, if you will, a voice calling out in the vast dark emptiness of the deep ocean. It's a powerful, resonant song, one that travels for hundreds, maybe even thousands of miles through the water. This voice has been singing for decades, a persistent and lonely call echoing through the Pacific. Yet for all its power, it's a sound that no other of its kind can seem to understand. So this is the story of a single mysterious whale, a creature whose song is sung at a frequency unlike any other ever recorded. It's a solitary note in the grand symphony of the sea, a mystery that's captivated scientists and dreamers alike for years. It really asks us a profound question. What does it mean to call out and never receive an answer? The ocean, you know, is a world of sound. Beneath the shimmering surface, where sunlight fades into an endless twilight, communication isn't a matter of sight, but of acoustics. For the great whales, the leviathans of our planet, their very existence is woven into the songs they sing. These are not just noises, they're complex compositions of moans, groans, pulses. They're used to navigate the featureless expanse, to find food, to attract mates, to maintain the intricate social bonds that define their communities. But what happens when a voice falls outside the range of hearing for all others? Picture, for a moment, the world of this whale. It's not a world of light and shadow as we know it, but one of immense pressure and profound blue. Down in the depths, the water is a near constant twilight, a realm where the sun is just a distant memory. The environment is a vast, three-dimensional space, stretching for miles in every direction with no landmarks to guide the way. It's a place of immense scale and quiet grandeur, where mountains taller than any on land rise from the abyssal plain and canyons deeper than the Grand Canyon scar the seafloor. This is the stage upon which our lonely singer performs, an arena of staggering size and profound emptiness, where a single voice can seem, well, very small indeed. The pressure here is immense, a crushing weight that would destroy any land dweller in an instant. The temperature hovers just above freezing, a chilling cold that permeates every corner of this deep domain. Yet life thrives. Great whales, the largest animals ever to have lived on our planet, navigate this world with an ancient and effortless grace. They're masters of this challenging environment, perfectly adapted to a life spent in the great blue solitude. They journey across entire ocean basins, their lives a continuous pilgrimage from rich feeding grounds in the cold polar waters to warm breeding grounds in the tropics. Their world is one of constant movement, a life lived on an epic and oceanic scale. Sound travels differently here. It moves more than 4 times faster in water than it does in air, and it can cover astonishing distances. The deep ocean has special layers, known as sound channels, where low-frequency sounds can become trapped and propagate for thousands of miles with very little loss of signal. The story of the 52 Hertz whale began not with a biologist but with the military. During the height of the Cold War, the U.S. Navy deployed a secret underwater surveillance system called the Sound Surveillance System, or SOSUS. It was a vast network of hydrophones, underwater microphones laid out across the ocean floor, designed for one purpose: to listen for the quiet hum of Soviet submarines. But in the process of listening for enemy vessels, the Navy operators began to hear other things. They heard the rumbling of underwater earthquakes. They heard the strange clicks of sperm whales. They heard the deep, haunting songs of the great baleen whales. The ocean, they discovered, was a very noisy place. In 1989, operators noticed something new on the SOSUS recordings, a sound that didn't match any known signature. It was a series of rhythmic pulses, clearly biological, but the frequency was all wrong. The calls were measured at 52 Hertz. This was peculiar. Blue whales typically sing between 10 and 40 Hertz. Fin whales sing at around 20 Hertz. This new sound was significantly higher, a lone tenor in a choir of basses. It was a whale, but unlike any whale anyone had ever heard before. The discovery was passed to scientists at Woods Hole, led by Dr. William Watkins. For over a decade, they painstakingly analyzed declassified Navy recordings. They mapped its movements year after year, following the lonely path of this single animal. The song was always the same, a short series of 3 to 6 calls. Each call lasted about 5 to 6 seconds. The calls were repeated at regular intervals. It was a consistent, identifiable pattern, the signature of an individual. To understand why the 52 Hertz song is so unusual, one must first understand what frequency means for a whale. Frequency, measured in hertz, is essentially the pitch of a sound. A low frequency produces a deep, low-pitched sound, like the rumble of a subwoofer. A high frequency produces a high-pitched sound, like a whistle. Humans can typically hear sounds in the range of 20 to 20,000 hertz. The songs of the largest whales are often so low they're inaudible to us without specialized equipment. Their world is deep subsonic vibrations we feel more than hear. Blue whales are the undisputed bass singers of the ocean. Their calls, around 15 to 20 hertz, are the loudest sounds produced by any animal. Those low, powerful vocalizations can travel immense distances across ocean basins. Fin whales, slightly smaller cousins, sing around a constant 20 hertz. Low-frequency calls lose less energy in water than high-frequency ones, perfect for long-distance contact. The 52 hertz call, however, falls outside this established range. It's significantly higher than the deep rumbles of blue and fin whales. It doesn't match the more complex, varied songs of humpbacks. The 52 hertz song is unique, too high for bluefin yet simple and repetitive like them. It's an acoustic anomaly, a square peg in a world of round holes. This difference in frequency matters. For whales, singing at the right pitch is everything. It's like tuning a radio to 98.7 FM when your favorite station is at 102.5 FM. For the 52 hertz whale, this is reality. The task of tracking a single whale across the vastness of the Pacific Ocean is a monumental challenge. Unlike tracking an animal on land with a GPS collar, scientists studying 52 have had to rely solely on sound. The original discovery and subsequent tracking were made possible by the U.S. Navy's SOSUS array, a network of hydrophones fixed to the seabed. These underwater microphones were placed to listen for submarines, but they became invaluable to marine biologists. By triangulating sound from multiple hydrophones, scientists could pinpoint the whale with remarkable accuracy. For years, Woods Hole received boxes of data tapes from the Navy, and researchers sifted through recordings for that one distinctive voice. The process was slow and laborious. They had to filter out the noise of shipping traffic, the sounds of seismic activity, and the songs of thousands of other whales. But from late summer through the depths of winter, the 52 hertz call would appear. It was a reliable, seasonal presence, a ghost returning each year to sing its lonely song as it migrated south for the winter. The data showed a creature of habit. Its path matched blue whale migrations in the North Pacific, and always from a single individual. Whale songs are, honestly, one of the great wonders of the natural world. They're not just random noises, but, complex, structured compositions that serve a multitude of purposes. For many species, especially the baleen whales, sound is really the primary medium for social interaction. In the dark and, seemingly featureless expanse of the ocean, where sight is limited, a powerful voice is the key to survival procreation. These songs are like invisible threads that hold their societies together, connecting individuals separated by hundreds of miles of water. They are, in a sense, the language of leviathans, a form of communication on a scale that's honestly difficult for us to comprehend. The most famous singers are, without a doubt, the humpback whales. Their songs are incredibly complex, consisting of repeating themes phrases that are arranged into a long, elaborate composition. A single song can last for over 20 minutes and may be repeated for hours on end. What's truly remarkable is that all the males in a single population actually sing the same song. This song evolves over time, with new elements being added, old elements being dropped, and when populations meet, they can even learn songs from each other. The label "the world's loneliest whale" is, of course, an anthropomorphism. We're projecting our own human emotions of loneliness and isolation onto an animal whose inner world we can never truly know. We cannot ask the whale if it feels lonely. We can't know if it's aware of its own difference or if it yearns for a connection it can never have. And yet the scientific evidence points to a life of profound solitude. For over 3 decades of acoustic tracking, its unique call has never been heard in the company of another. It's always a solo performance, a voice crying out in the wilderness with no audible reply. The mystery of its song deepens when we consider what these calls are actually for. In baleen whales, these loud, repetitive songs are almost always produced by males and are believed to be primarily a reproductive display, a way to attract females. If this is the case for 52, then its life is a particularly tragic one. It may be spending its entire adult life singing a love song that no potential mate can hear. It's a broadcast of availability and fitness that falls on deaf ears, a serenade performed to an empty concert hall. Its calls are a perfect biological signal sent on the wrong channel, an unanswered plea for connection. Some researchers offer a sliver of hope, though. It's possible that other whales can hear the 52 hertz call, even if they don't respond to it or sing at the same frequency. It's also possible that the whale is not entirely alone. Ultimately, the life of the 52 Hertz whale remains a profound enigma. The story of the 52 Hertz whale is a reminder of how little we still know about the acoustic world of the ocean. The sea is filled with a bewildering array of sounds, many of which remain a mystery to science. For every whale song we can identify, there are countless other. This human-generated noise is a growing problem, is creating a kind of acoustic smog that is drowning out the natural sounds of the ocean. For animals like whales, who depend on sound to survive, this can be devastating. Now just take a moment. Close your eyes and try to imagine it. Imagine you have something important to say, but well, no one turns their head. This is the world we imagine for the 52 Hertz whale. It's a powerful thought, one that speaks to a fundamental need for connection that we all share. Let it be a call to action, a call to listen more closely to the natural world, a call to protect our oceans from the rising tide of noise and pollution. But we may also learn something profound about ourselves and our place on this remarkable living planet.